Question 7. Maximum mark is 7. When you print this question off from the IB question bank, it actually says consider f of x equals log k bracket, but for it to make any sense it's got to be log to the base k, so I apologize for that layout. For x is between 0 and 2, where k is greater than 0, the equation f of x has exactly one solution. Find the value of k. Alright, so f of x equals 2 has exactly one solution. Let's substitute that in. So it must mean that 2 is equal to log at the base k of 6x minus 3x squared. So when we raise k to some, when we raise k squared, that's going to give us 6x minus 3x squared. So those two are equivalent. So we're using the log rules. What we can do now is we can say that 0 is equal to 6x minus 3x squared minus k squared. So essentially what we're doing is we're generating a quadratic. Because now we've got a quadratic, we can look at this. We can say it's got exactly one solution. Because it's got exactly one solution, if we're looking at the quadratic formula or the discriminant must equal 0. Or b squared minus 4ac equals 0. So let's have a look at what we've got. So our b is negative 3. So we've got, our b is 6. Let's get the signs right. 6 squared minus 4 times negative 3 times negative k, and that k squared, is equal to 0. So we've got 36 minus 12k squared is equal to 0. So 36 is equal to 12k squared. 36 divided by 12 is 3, is equal to k squared. And that must mean that square root of 3 must equal k. So now we've found the value of k, non-calculator paper. Where are our marks available? So let's do the marks in yellow. We've got M1, correct equation without logs, so that would be here. Let's go A1. Valid approach, making it equal to 0. Recognizing the discriminant must be 0 seen anywhere, M1. Correct discriminant here, A1 or value above. Correct working, k squared equals 3. So we've got 1, 2, 3, 4, 5, and then A2 for a final answer of. There are other ways of doing this. You can complete the square, etc. But because it's mentioned discriminant and exactly one solution, I prefer to use the discriminant.